For those who don't know me, my name is Nick Randolph, and I currently run a company called Built to Roam, where we focus on building mobile, cross-platform, desktop, web, full stack kind of applications. Tonight's session is going to be on the Uno platform, and if you've got any questions afterwards, feel free to hit me up on Twitter, or stick around after the user group and feel free to ask questions. Now you might be wondering, okay, what's this WinUI everywhere? Okay, so there's a lot of backstory here, but essentially if you think back to the days of Silverlight and to where Microsoft has gone in the last sort of decade, one of the things that we're trying to solve is this ability to write code once and have it run everywhere. Okay, and WinUI is Microsoft's latest take on XAML. It's their latest take on a Windows development capability, and it kind of builds on everything that they did in the UWP space. And so this concept of WinUI everywhere is the ability to take that concept of WinUI or XAML and C# and be able to have it running everywhere. And so this is the tagline for the Uno platform, and this is where we're going to cover off today. So let's dig into the problem definition a little bit more before we look at the Uno platform itself and how it solves those. We're going to start with these three different items. The first one being, okay, cross-platform is hard, okay? If you look at that space, then quite often people are coming from the perspective of, say, having an iOS and app and wanting to, produce it on Android or take it to Windows or Mac or Linux. Or they may be taking, a Windows app and wanting it to run everywhere. Or they want to have it, they've got an existing app and they just want it to run on the web. And every time, each of those scenarios boils down to basically taking a code that's running somewhere and having to recode it for a different platform. And fundamentally, that's a problem for two reasons. Firstly, it's costly, okay? Because you've got to rewrite the same code. You might have taken some Objective-C code and you're going to rewrite it into Java or Kotlin, or you're going to rewrite it in JavaScript and HTML and pick a framework there for the web. And then the second problem is, okay, well, now that we've set up two teams and we're now producing these apps, how are we going to keep them functionally the same? How are we going to make sure that the code that we write for one platform is the same across all of those? So not only are you duplicating the effort, you're also having to make sure that you've got feature parity and that the implementations are exactly the same. Otherwise, essentially, you've got two apps that are going to be working differently and you're going to have different support matrices for them. So that's the kind of first section. The second one is that there is a whole host of existing legacy apps out there. So whether those be done in Windows Forms, WPF, or even Silverlight, we're still trying to clear up that mess. But the reality is that we're trying to bring those forward into a modern world, right? Now, whether that means bringing it forward to a mobile device on iOS or Android, or rewriting it for the web, the reality is that that's a costly exercise. And ideally, if they've been written in C#, we should be able to reuse a lot of that code, okay? So we should be able to take that Windows Forms app or the WPF app and have it reskinned and made available for the web. The third problem sort of area is around skills, okay? So if we're building up a team of iOS developers and Android developers, and then we've got our mandatory web developers, we've essentially got three sets of resources there, potentially more if we're supporting Windows and Linux, etc. And keeping those teams engaged, growing them, skills development, that's hard. And again, it comes back to essentially they're responsible for writing the same thing over and over again, and it's a matter of, okay, well, which platform's going to lead that and which one's going to follow, and then how do we get consensus between the teams on the architecture and the overall structure? That's a hard problem to solve. Whereas if we can have one technology where the majority of our developers are engaged with it, maybe C#, .NET, XAML, and then have it building an app for every platform out of that, that limits the amount of sort of skill development we have to do across these various technologies. Now, this isn't to say that this is going to solve everything, because occasionally you'll need to get an expert in who knows the in-depth workings of iOS, and maybe they know how to do authentication on Android. But the reality is that those are one-off type things where you can engage a consultant, or you can get somebody who's very deeply engaged with that platform to come in and solve that individual problem. But the bulk of code, particularly if we're building enterprise apps, is very bulk standard. It's very forms-driven type thing where it's page after page of layout here, layout there. Most of that stuff you don't need to be an expert on those individual platforms in order to generate that layout-based code and that sort of baseline code that is the foundations for most of those apps. So the concept that the Uno platform came up with is this ability to take what Microsoft have done in the UWP and the WinUI space and have it broadly available across virtually every platform. And so essentially, if you can run .NET on a platform, the goal is to have it support the Uno platform. So if we look at the bottom of this sort of stack, we've got the individual platform frameworks, okay? So we have WinUI or UWP on Windows. We've got, things like AppKit and UIKit on iOS, and we've got the foundations of those. Now, Microsoft's done a great job in the sort of the Xamarin and now .NET for iOS and .NET for Android space to provide an abstraction in C# for those. But essentially, if you're going to use that abstraction, you still end up having to use the UI components that are native to iOS and native to Android. So what the Uno platform provides on top of that is basically an abstraction that matches or uses the UWP/WinUI as a spec and has it available across as an abstraction across all of those. So you essentially have to build the UI once and it will work across all of these platforms. And unlike some of the other multi-platform frameworks that are out there, the goal with the Uno platform is to have a pixel-perfect rendering on each of those platforms. So if you use a button on an Android in the Uno platform, it should be exactly the same and look exactly the same on iOS. Okay. This is a bit of a divergent away from a sort of a design philosophy from probably 5 years ago, maybe more, where there was a drive to basically make sure that apps were very platform specific. So an iOS app looked like it belonged on iOS, an Android app looked like it was styled for Android. The design mentality has evolved from that, and the branding of your application or the branding of your company and the design of your application is much more paramount now. And so it no longer matters to a greater degree that you might have a button styled for your company on iOS and Android and they look exactly the same, rather than picking up the default look and feel from the individual platforms. So this leads us into sort of this next slide, which talks about the different kind of rendering capabilities that different platforms have. So these are the leading contenders in this sort of multi-platform or cross-platform space. So on the right-hand side, we've got React Native and Xamarin, which is now MAUI. And they basically use the native rendering components for the platform, right? So if you use a text block, you'll get a text block that's specific to those particular platforms. And so your applications out of the box look like they're platform specific. They look like an iOS app and they look like an Android app. On the left-hand side, we have the sort of these canvas rendering technologies. So we've got Avalonia and we've got Flutter in the bottom corner. And so those basically, their philosophy is that the device is a canvas. And so they're going to draw every component natively. And so they're responsible for every little bit of layout. And in the case of things like Flutter, that gives them great control, okay? But on the flip side, it also means that they have to rebuild everything, right? So they have to build the text input control. They have to rebuild support for localization, support for accessibility. All those things they have to build themselves, okay, from the ground up, because you're treating everything as a blank canvas. The Uno platform kind of sits in the middle. It basically, on most of the platforms, it does build on the device rendering capabilities, right? So if you're running on iOS, it'll use the native components that are specific to iOS. However, they're stripped back and they are rendered in a pixel perfect way to make sure that they look exactly the same for your application on every single platform. Uno platform sits in the middle because it does have some capabilities of rendering to a canvas, okay? So on certain platforms, because the back end isn't suited for those particular platforms, they've adopted a skier rendering capability there. So, a button on the WPF implementation actually uses skier rendering and to actually generate that look and feel. Okay, but as I said before, the Uno platform is now responsible for everything for that particular platform. Okay, so there's a lot more effort that needs to go into supporting those. The last thing that is worth pointing out is that all of the controls, because they've come from the XAML UWP/WinUI space, are these things called lookless controls, or controls that have got a template behind them. What that means is that you can actually take the template, you can redesign the template to your heart's content without impacting the behavior of the control. Okay, so a combo box, if you restyle it, so you basically strip out all of the templates and you rebuild the templates yourself, the functionality of that combo box is still going to be the same. It's just going to be the look and feel of it that's varied. Okay, so this diagram's getting a little bit big for the screen, but essentially we're taking this single bit of XAML and we're having it available on all of these different platforms. There are a couple of heads that are not there, so we do actually, as I mentioned before, there is a skier rendering for WPF that's not on there, and I think that there's a second renderer for Linux that's not on there as well at the moment. So But with that in mind, I actually want to switch across, and let's actually take a little bit of a walkthrough of a demo. So there is a couple of .NET new templates. So if you want to get started, you can either go through Visual Studio, download the Uno extensions from the marketplace, or you can download the Uno.NET templates from NuGet and install those. If you've done that, you can basically go to the command prompt and run up a new app just using the .NET new command. Okay, so here we're basically using the vanilla Uno app template, and I'm actually going to include the --VS Code extension on the end, and that's just because I want to be able to run this in directly from Visual VS Code. It just adds a couple of extra files that just makes it easier to launch the application without me having to go and reconfigure everything. So what we should see is it generates the solution. Okay, so it's going to generate projects for each of the different targets that we're going to make the app available for, and then it's going to call .NET Restore on those to get us started. And once this is done, we're going to go into there. So we'll go and launch Visual Studio Code. And what we should see when we've launched this now. To get started in Visual Studio Code, there is also an Uno platform extension for VS Code that is worth downloading, and that will help everything get started in terms of running and debugging your application. So I'm just waiting for a minute or so because that extension will actually kick in a second and should prompt us to do a .NET Restore. There we go. And down the bottom here, we should see that it's picked up our solution, and I can use that to hot swap to the target or the destination that I want to debug. So I'm going to pick the WASM target here because we're going to launch for the web. Now, one little change I'm going to make in here, I know that my machine sometimes takes a little while to kick everything off, so I'm just going to extend the timeout. So this is the timeout for when you hit run to the point where everything's actually built and running, and it just takes a few more seconds on this machine than it does on my grunty development machine that I normally use. Okay, so we set the debug target to be the WASM head. I'm going to press F5, and we should see down in the debug console that it's going to run .NET Run, and it's going to launch our browser to step into our application. So this will take a minute or two, and while it's doing that, I'm going to switch across to the source code and find our app.xaml.cs. So if you're used to building, say, a WPF or a UWP app, the file structures that are here will be fairly familiar with you. So you have an app.xaml or an app.xaml.cs, which is essentially the entry point for your application. It sort of represents the application. And then you've got main page, which is kind of like the first page of your application. So I'm actually going to put a breakpoint on the onLaunched. And when this does actually come back, you'll see it actually start the web application down here once .NET runs completed. Hopefully it should do that in a second. Okay, there we go. So you can see that it's actually listening on a URL there. And with a bit of luck, okay, so it's loading the Uno app here. So this is the WebAssembly. So there is a little bit of an initial download to actually pull all the resources locally into the browser. And you'll see that it's actually hit our debug breakpoint here. So we now have a fairly full debugging experience, so I can hover over variables and actually drill down and inspect them like you'd expect from a debugging experience. Your usual F keys work, so I can step into the code, etc. like that. I'm just going to let that run now. And we have our vanilla Hello World application. Okay, the app doesn't look particularly great right now, so let's just add a little bit of functionality. So I'll come back to my files. I'll go to our main page where you can see the XAML for our Hello World. I'm going to add in a slider here. And you'll notice immediately that we're actually getting some IntelliSense, both for the XAML, and you'll actually get it in a C# as well. So I'll give this a name. I'll call it slider. I'll make sure that tag is closed. And we're actually going to bind the value of that slider to the text block here. Okay, and I'll just hit save on that. And what we should see is that the hot reload has kicked in, it's reloaded the page, and you'll notice that as I drag this slider across, it's updating the value there, right? So it's quite a rich debugging experience, even for building web applications. So I'll actually stop that, and the last thing we're going to show you just in Visual Studio Code while I'm here is I'm actually going to switch across to the GTK head. So down on the left-hand side here, you'll actually see that each of these projects kind of represents the different targets or the different head projects for our application. You'll notice that there's a single project here for mobile, so that covers iOS, Android, macOS. Similar to if you've started looking at Maui, they've got a similar construct for their, a single project format for all of that stuff. And then the other targets that are available, whether they're Linux or WPF, are all listed down as separate projects still. So they're not included in that single project format at this stage. So let's run up the GTK. So this is essentially one of the Linux heads. And we'll set that as the debug target as well. And we'll give that a run. Okay, so it's just building now. And so what I've got running here is I've actually got WSL running locally on my machine. And so that means that essentially we're able to run Linux applications on our Windows box. And what we should see is that the GTK application is going to launch. And again, I've still got that debugging experience. Okay, so it'll actually hit breakpoints. We've got the sliders working. We can go and do hot reload, etc. there. So, okay, let's switch back to our slides. So the Uno platform's been around for quite a few years. It kind of dates back to roughly the time of sort of Windows Phone and the work that Microsoft was doing around, bringing forward the XAML platform from the days of Silverlight and WPF. And so at that point there was things like Xamarin, starting to surface up, and this concept of being able to run an application or build an application once and have it run everywhere kind of was spawned. And so that was sort of inspired back in 2013, and then it made open source in 2018, along with the first cut of the WebAssembly version of it. And since then, the team's been fairly aggressive in terms of publishing new updates. We're looking probably around 6 to 8 a year at the moment. And so you can see the timeline kind of matches with various releases of both the Windows capabilities, so whether those be updates to UWP or the release of WinUI, but also updates from Microsoft around the support for new versions of iOS and Android and macOS. And as we sort of get into this year and the latter half of last year, we're adding in the Net6 support. So with the GA of Maui, Microsoft also released the Net6 mobile support. Okay, so if you've worked in the Xamarin space, then this is kind of like the next generation of Xamarin. It's basically, instead of calling it Xamarin for iOS and Xamarin for Android, it's now .NET for iOS and .NET for Android, with the idea that they're all now this common Net6 base class library. Okay, there's still different runtimes, but the base class library is now uniform across the different targets. Okay, in terms of where we sit in terms of licensing, the Uno platform is completely open source. You can go to the repository and actually monitor the activity there. It is a fairly active repository, and basically every time a pull request is merged, there's a new version of the Uno framework that's available for you to develop on. They do static releases, or sort of official releases every sort of 6 to 8 weeks. But the idea is that if you submit a bug and it gets fixed, you can grab a copy of the Uno platform and start working with it as soon as it's gone through that sort of merging process. They do offer a support model, right? So if you're going to use this in an enterprise setting, or you need a support model for customers, they can engage with that for paid-like support. Ironically, Microsoft is actually Uno's largest source code contributor. And this is primarily because everything that Uno does is based originally on the work that Microsoft did with the UWP and WinUI platforms. Okay, so all of the controls that were available for those platforms have been brought forward and made available across the other platforms. For example, the date time picker, you can see some of the stats here. This code was able to be taken and reused for building out the date picker capabilities for the other platforms to make sure it behaves and looks exactly the same. It also means that other libraries can come across to the platform. So basically any net standard library can just drop in and work. Okay, we are in a C#.NET world, right? So you get all of that reuse. So any library that you might have come up with, and that does some data processing, or some clever graphics manipulation, those, if they're .NET standard libraries, will just get up and running on the Uno platform. So you can basically drop those in, reference them, and use them anywhere. Anything that's UI bound, there is an adaptation that needs to be done for the Uno platform, but so long as you have built the controls for UWP and WinUI, that process is relatively straightforward. It's really a matter of just testing it for the various platforms, and you can get it up and running that way. We've also got some contributors from various higher level frameworks, so things like Prism and Reactive UI that are available on the platform as well. Here's an example of the work that Infragistics did for the Uno platform. So all of these controls are available for you to use as part of your application. With version 4 of the Uno platform, which came out late last year, the team had moved on from basically just providing a core base level of technology. And with version 4, the tagline is that we're putting the platform back into the Uno platform. And so the idea here is that rather than just providing you the base framework that you can write applications, there's still a large amount of stuff that can be done to improve developer productivity. So these are things like the toolkit, the Visual Studio Code, Figma support, those types of things. Anything to basically improve the flow of building an application from design all the way through to publishing your application. So we're going to go through a few of those today, and this is where the team's putting a lot of focus in terms of making sure that we're the most productive platform for building cross-platform applications. We'll start off in the Figma world, okay? And so if you've ever done work with designers, which I'm sure most of us have, you'll notice that there's obviously this big divide between what the designers come up with and the code that we eventually write. And so this divide often happens for a number of reasons. And typically it's because the designers work in a tool that we as developers are not very familiar with, and that they then go and basically drop the designs off to us, and then we basically have to go and try and make it look exactly the same. So there's this handoff problem, okay? It's also relatively expensive because we essentially have to take the designs that they've come up with and then basically come up with use our development tools to basically come up with the same design, okay? And then of course that doesn't then round trip very well, okay? What would be really good is if what the designers generated could then be used within our application. And so on the other end of the spectrum, we have these things called design to code, okay? So these are basically sort of 4GLs that allow designers to pull pieces together that look like an app, behaves like an app, generates an app, but doesn't look that great. And often, you know, it's fairly limited in what the designers can do to make the application look amazing, okay? One of the beautiful things about XAML is that it's very, very designer friendly in the sense that they can restyle controls to your heart's content. However, there is this handoff cost because a lot of the tools that the designers work in doesn't hand off particularly well to what developers like to work in. And so the idea behind what the Uno platform team's been working on is a couple of plugins for Figma that tries to provide this sort of middle ground, which allows the designers to stay in a tool that they're familiar with, so Figma, and yet developers can basically extract the designs out of Figma, use the XAML that's generated, and just drop it into their application. Okay. The idea here is it should shorten that loop. It should generate XAML that's working XAML, and that can ideally be round trip or at least minimal changes in order to get it up and running. Okay. So there's two components for the Figma plugin. So there's actually a component library. So this is essentially a Figma design template that you can go and download and get started with. And it provides all of the core components that a designer would want to use within when they're building up the look and feel of their application, right? We'll see that in a moment. There's also a plugin, and so this plugin basically gives you a live preview, so the designers can actually see what their application is going to look like, not just in Figma, which obviously is going to look great, but actually as running code. Okay, so think of this as a round trip of the XAML. So the XAML gets generated out of the Figma designs, it then gets surfaced in the live preview as actual running code, right? So the XAML's been generated, it's been essentially compiled and running actually in the previewer. And then there's a bunch of other things that the XAML should take care of for us. Okay, things like localization, support for bindings, and support for navigation are all things that can actually be generated from our design. So I'll see here, there's a very quick video which kind of sort of walks through some of the capabilities of Figma. But rather than sort of, you can go and download this and watch it at a later stage, but we're actually going to jump in and actually have a look at this actually in Figma itself. Okay. And to do that, we're going to take a look at a sample commerce app. Okay, so it's got a number of screens that are already pre-canned for us so that we can actually take a look at how they're constructed. And then you can use those as the basis for coming up with your own application as well. So let's have a look. Let's go to, where is my figure gone? There it is. Okay, so if we scroll up here, okay, so this is the UNO Platform Material Toolkit. So this is downloadable from the UNO Platform website. And it comes with a bunch of getting started instructions, okay? So there is a lot of components in this sort of template. And so this provides some basic instructions on how to get started with things like colors, typography, and how to get started with a new project, okay? We'll just quickly step through some of the pages that are in here. So things like setting up the themes, you can come in here and adjust your color palette. You can see what the different typography or the different fonts are going to look like. And then you can see things like app icons, etc. And just go ahead and use those as the basics for setting up your own application. There are also some sort of higher level components that we cover off in here. So if we scroll into here, we can basically see things like your buttons. And the important thing here is that, okay, it's not just a singular button, but there are different variants on that button. So you may decide to have use the elevated out of focus button, which I think is this one. And so you can take the copy of that and actually drop it onto your design. Okay? So rather than having to take a button and then restyle it, the idea is to make it easier for designers to basically grab the components that they want and copy it into the design that they're building. There are also some other preset components, so things like cards, forms, list items, etc. And then we have our sample app. And the idea here is that it provides a sort of a basic sort of getting started place for somebody coming up with their own design. And what we're going to do here is actually click on one of these screens, so the search product. And I'm just going to show you, this is the plugin, and we're going to see this actually running. So I'll hit the refresh button on this. And so what's being done behind the scenes is that it's generating the XAML that corresponds to that design. Is actually loading it into essentially an UNO app that's running as a WebAssembly app in the Figma plugin. Okay, so it's a bit like Inception. It's kind of like an UNO app inside an UNO app inside an UNO app. Okay, and we'll see in a minute that we can actually take that XAML and use it in a real application. Okay, let's just step back to the slides for a minute. So one of the other components that the UNO team has worked on is the themes library. Okay, so this is basically a library to allow you to essentially drop in or to change the theme that's used by your application. So if you grab a new UNO application, the theme that you're going to get that comes out of the box is the Fluent theme. Okay, so it's the Microsoft Windows theme language, design language. And so that's what your application is going to look like on all platforms. So remember, the UNO platform generates pixel perfect or identical looking applications across all these platforms. So if you then want to restyle it, as quite a lot of people do, to make it look like an Android app, so using the Material design language, you can do that using the Material theme library. And similarly, if you want it to look like an iOS application, you can drop in the Cupertino theme library and it will be styled accordingly. The other thing that the team's working on is this is a toolkit. So you might think, okay, but doesn't Microsoft provide all of the base level components that we need for building our app? Well, if you think about where Windows is coming from, it's a desktop, predominantly desktop and tablet kind of interface. And so the controls that come out of the box with UWP and WinUI are predominantly desktop components, okay? So they don't have things like a navigation bar and a tab bar because you wouldn't expect to see those on most Windows applications. However, if we're building an app that's going to run across all these platforms, then we're going to have some controls that actually look like they're appropriate for a mobile app. So things like a nav bar and a tab bar and things like chips and segment controls and stuff like that are all the things that we kind of know, even though we may not know what they're called, as part of a mobile application. Okay, so the toolkit that the UNO platform brings, or has been working on, actually brings some of these components and makes them available again across all of the supported UNO targets. So a couple of the other controls are things like a drawer, so this is like a pop-up container from the bottom, and an auto layout control that allows you to basically lay things out on a page. And you'll see a lot of this coming out of the Figma designs where you're dragging things on and they'll auto size or auto fill based on the size and dimensions of the device that it's running on. Another area that the team's been working on is the idea of extensions. And so if you're used to building, say, an ASP.NET based applications, you kind of be familiar with some of this notion. These are the idea of extensions, because when you new up an application, if you go into your your startup files and your program files, you'll see that there is a host that's been generated, and you're basically enabling a whole bunch of things on that as part of that host building experience to enable certain capabilities in your app. Okay, so it's things like it starts up the DI container so you can inject dependencies through your code, and all of that kind of nice behavior that we expect in terms of adding like authentication and navigation and routing and things like that. In the web space, we've had that for years. Okay. In the mobile space, we haven't really had that concept. I mean, yeah, sure, there's been a whole bunch of dependency injection containers that you can use. So things like AutoFac, you can bring those into your application. But the core app framework didn't really know about those. So we've seen this in the MAUI space. MAUI now has this sort of host builder kind of experience as the basis of their application. You can go and register things with their dependency injection container, and then you can retrieve them at a later stage. And this is particularly relevant when you're using view models and you want to inject services, etc. So the Uno team's been working on a similar sort of thing, and this is kind of based on the work that Microsoft's done, so the Microsoft extensions. The Uno platform has basically taken those and basically using those to bootstrap an application. And so what we'll see in a minute is that we'll actually start an application not using the vanilla template, we're going to use the extensions template, and we'll see that a lot of this stuff is set up for us as part of that. So things like the ability to do navigation and the ability to do logging and HTTP requests and things like that all comes through this host builder experience where you can enable things on app startup. Two of the main extensions that are worth noting are the ones for navigation. Okay, so the built-in sort of navigation mechanism for UWP and Uno applications is the ability to navigate from one page to another. Okay, so it's typically a frame-based navigation. But typically, most applications are more complicated than that. A lot of applications will use like a navigation view, so like a pop-out menu from the side that allows you to change the page that's in focus. Or a tab bar, so you've got a number of tabs that allow you to switch what page is in focus. So those are all sort of the broader case of navigation. And so the navigation extensions chooses to abstract or provide an abstraction there, along with making it easier to glue in your view models, right? So instead of you having to new up a view model and work out how it's going to get paired with the various views, the navigation extensions does that for you. The other one is the reactive extensions. And so if you're sort of familiar with the XAML space, you'll be fairly familiar with MVVM. Okay, so it's this model view model, essentially equates down to data binding. Okay, so we're going to generate a view model and it's going to be data bound to our view. We're going to surface properties on our view model that are then going to set values on our view. So you can think of it almost like the state of our view. And quite often as the state changes, we're going to have to raise events to let the UI know that it needs to update. So this is the standard iNotify property change that we've all implemented several thousand times, or we've used a base level class like observable object from the community toolkit that implements it for us. However, one of the challenges with this sort of MVVM approach is that it doesn't lend itself very well to reactive style programming. So this is a trend over the last 5 years or so, where as the user interacts with an application, they're essentially sending messages into and modifying the application state. The application state then bubbles up the new state that then should be reflected in the UI. Okay, so that's kind of like this reactive pattern that should be we should be able to use for our applications. And so there's been attempts by various teams, Comet being the last one, to actually make a version of this work well with XAML and data binding. The MVUX, or the reactive extensions model that the Uno platform are working on, essentially allows you to build your view models as you would normally. Use a number of code generating techniques to essentially allow you to build reactive style properties and states and things like that within your view model, and then use this as the glue that then generates a bunch of code that does the data binding for you. Okay, this is a whole session on its own. I'm not planning on delving deep into that, but reach out to me afterwards if you are interested in that, and we can definitely help you to get started with it. Okay, the VS Code tooling we've kind of seen before, so things like code completion with IntelliSense, Hot Reload, and the ability to actually run our applications from VS Code. Obviously all well and great. Most of us will stick in Visual Studio, as we're about to see. So with that, I'm going to switch back to my code window, and we're going to new up a different application. And as I mentioned before, this one is actually going to use the extensions template. Okay, so we're going to go .NET new, Uno app, extensions. And now we're actually going to launch this in Visual Studio. So we'll do let's try that again. I'll try and find the solution file. There we go. Now, the first thing we need to note when this launches is that our solution structure is a little bit different from what we saw in VS Code. Okay, so it's laid out slightly differently. So there's this platforms folder. This part will be familiar. Okay, so we had the single project that targets iOS and Android. So that's our mobile project. And then we have the various other targets that are available there. While we're here, I'm actually going to multi-select those. When Visual Studio catches up, and I'm going to right click on those, and I'm actually going to unload. And you might be thinking, okay, why are you doing that? The reason for that is that Visual Studio is inherently bad at dealing with cross-platform applications. This is true for Maui, and it's true for Xamarin Forms. Essentially, if you're running into performance problems, which I will often do, or you just want to get a little bit more performance, just unload the projects that you're not working with. And so what we'll see here is that when we go to run our application, rather than trying to restore and trying to run all of those, or to build those applications, it'll actually just ignore them for the time being. So we're going to set our Windows project as our startup project. And we'll kick that off and start that while I'm talking through the rest of the structure here. So the other projects we've got in here are, we've got a unit testing project. Okay, so that's this first one here. And we've actually also got a UI test project. Okay, so one of the challenges with building cross-platform apps, or building apps across generally, is how do we go about testing not just the business logic of our apps, because hopefully if we're using things like dependency injection, writing unit tests for testing the business logic should be relatively straightforward, and we can do that in an isolated way. However, a lot of the frustration with building, mobile or cross-platform apps comes with the, what happens when my UI doesn't behave properly, or is not doing the thing that I want it to do, or it's not navigating correctly between the pages, etc. And so being able to write UI tests and actually run those UI tests just gives us a leg up in terms of the ability to actually test our application. Okay. Well, we'll come back to our solution structure in a second. I'll just show you the app. Very basic, it's 2 pages. You will notice that it's got a different style. Okay, so the material styles are actually enabled by default because we brought in that material library. And I can navigate to my second page, and this is using that navigation extensions that I talked about a minute ago. Okay, so we've got the navigation bar at the top. On the first page, it doesn't have a back button. When I go to the second page, because it understands things like that there's a frame there, that it's got a back stack, it automatically puts that back button there for you. Okay, so I can just go back to there. Okay, so that's our app running. We're gonna modify that to look a little bit more like the commerce app that we saw in Figma in a minute. But before we do that, let me just bring back our Solution Explorer. So I mentioned that we've got the 2 testing projects. The last 2 projects we've got here is essentially a class library. Okay, so it's a net standard class library. You can update it to net 6 if you like, but essentially it gets created here. So this is where all of our business logic, so our view models, our services, all of the stuff that actually gets our application running is going to sit in that particular class library. It's nice because it's a net standard library. We can test it, run all of the unit tests without it being attached to any particular UI framework. We then have our UI project, and this is actually a shared project. So a shared project is one where when you reference it from the target project, it's essentially pulling all of those files into those projects when it goes to compile them. And we could have made this a cross-platform library, but again, Visual Studio doesn't actually perform very well when you're doing that with a multi-targeted cross-platform library. because what it will try and do is it will try and build for every single target every time you rebuild it. Okay, so shared project is actually a better or quicker developer experience for that. Okay, and in here we've got all our views. Okay, so we've got things like our main view and our second view page. And the one thing I wanted to point out is that in addition to our XAML and our XAML.cs page, we have this XAML.host.cs. Okay, so I mentioned before that we have this notion of a host builder and sort of enabling services on app startup, and this is where they're all done. So this builds our app host. If you're doing Maui development, you'll see a similar sort of thing as part of the boot up of a Maui application. And so this looks fairly similar to what you'd expect in a sort of an ASP.NET minimal API type application, where you're newing up a bunch of services or you're adding a whole bunch of services to your host. Okay. Let's zoom in a little bit so we can actually see these in a little bit more detail. Okay, you can see here that we've got the ability to configure backend services. You'll also see that our routes, so this is the way our navigation is wired up. Okay, so this is a pairing between our main page and our main view model, second page, second view model, and the corresponding routes for those. Okay, so this is basically the routing that powers our application. Okay, so let's get started making this look a little bit more like the commerce application we saw in Figma. So before we get started, I'm actually going to just grab another package ref in here. So we're just going to drop this in here like that. So we're actually bringing in the community toolkit, the MVVM library. So this will give us a common base class called observable object, which implements iNotify property change. So it just means that we can write properties and bubble them up. And as you will see, I'm not using the reactive pattern as part of this, this demo. The next thing we're going to do is we're actually going to flip back to Figma. And this page that we saw rendered in Figma before, we're going to switch across to the XAML tab. And you can see that this is the XAML that's being used to generate that particular view. So I'm actually going to click on the copy XAML button down here. And we're going to switch back to our application. I'm going to go back to our main page. I'm going to select the existing XAML and actually replace that with the generated XAML. Now, I know because I've done this a few times that there's going to be a bit of a build error here. So let's see if our IntelliSense kicks in. Okay, so it's going to add this namespace in there. And then we should be able to run our application. Now, obviously, I haven't powered this with any data. So what we should see is something that looks similar to what we saw in Figma, but obviously it's not going to have any data to be displayed. Give it a second or two. Okay, so basically this is it's got the tabs at the bottom and our search interface, and ideally we'd have a list of products there. So let's go and wire up that with a little bit of some services in here. So we're going to go to our backend, our service code. So under presentation, we can grab our main view model. I'm going to scroll down here. Now, normally I'd put these in separate files, but for the time being, I'm just going to drop in essentially some classes that are going to represent the service that we're going to be calling. Okay, let me just add that using at the top there. So we have a DummyJSON endpoint, and so we're going to be calling a path called products. Now, this actually correlates to, let me see if I can bring it up. DummyJSON.com. So if you ever need just to pull some JSON from somewhere, it's basically just for demo purposes, you can do that. So it's got things like products, users, posts, comments. So if you're building some demoware, it's like a great resource because you can just basically wire up a dummy endpoint to this. So we're going to import that as our JSON endpoint, and you can see here I've got basically some POCO classes that basically map to the data that we're going to get back from there. So this was looking at the product endpoint. If I go back to there, you can basically see where's it gone? Products, get all products. So this is the product endpoint. If I go and click on the show output, you can see that we've got essentially a list of products that we're going to use in our application. All right, let's come back to our app for a second, and we're going to come up to the top here. And what we want to do is actually inject that endpoint into our main view model, because that way we can call the endpoint and actually retrieve our products that are then going to be bubbled up and used within our application. So I'm going to drop our dummy endpoint into there. And we're going to end up calling load products and passing the endpoint like so. And get Visual Studio to generate a bit of code for us. And in here, we're going to call our endpoint. Like so. Now what this response is going to have, it's going to have a property called products that we're going to then need to map and expose through our main view model. To do that, I'm going to change our main view model to inherit from observable object. Okay, so that's coming from that community MVVM library. Oops, I misspelled that. Let's get Visual Studio to correct that and import the right thing. And we're going to create an observable property. And so to do that, we make it private. And so you can think of this as the backing variable for our properties, right? So the actual property is going to be co-generated for us using that tag. So this is going to be our product. And we're going to call that items. And the reason I'm calling that items is because if we go to our UI, we'll actually see that the list view is actually data bound to a property called items. So I could either change the XAML or I could change the code. So now we're going to grab that items, and down here we're going to do items, and note this is going to be uppercase items because we actually want to use the property to make sure that the property change event gets raised. So we're going to go items equals response.products. Okay, so that should power up our application in terms of the backend service. But the question is, okay, well, where's it getting this endpoint from? Because all we've done is added a bunch of interfaces and classes down here. We haven't really done very much. I mean, even our endpoint is actually an interface. It's not even a real class. Okay, to get this up and running, we're actually going to go back to our host setup. And firstly, I'm going to disable the reactive view models for a second. We're not going to make use of those. And we're going to actually inject a service into here. And for that, we're actually going to use refit. So we're going to replace this service logic here with this code. And there's a couple of namespaces to import. And so because we're importing refit, so refit's basically going to take our interface and generate a class that's going to map to it and an endpoint that we're going to be able to call. Now the only thing that's really missing is the actual URL that we need to call. And for that, we're going to add that into our settings file. So I come over here, go to app settings, and in here I'm going to specify that our DummyJSON endpoint, the URL that we're going to use is there. Okay, so with all of that, we should be able to run up our application, and with a bit of luck, we're going to end up with some products. And so as part of startup, it's now going off and hitting that endpoint, bringing back the list of products. Now what would be really nice is if I click on those, we should navigate to another page so we can see the details of it. Okay, let's just wire up that using a little bit of navigation. So I'm going to come back in here, and on our list view, we're actually going to attach a property onto here to tell it where to navigate to. So we're going to do UEN, which is our namespace, navigation, request equals second. Now you think, okay, where's that second coming from? We go back to what we were looking at before, which is our routes. That second corresponds to this second down here. Okay, so that's the name of the route that we're going to. The other thing we're going to do is actually change this from a view model, a view map to basically a data view map. And essentially what we're saying here is that the navigation framework should expect for a product to be passed into our second view model. Right? And so that's how the second view model will get a product injected into it. However, our second view model currently doesn't know that it's going to get a product injected to it because it is just a vanilla class right now. So we're going to change this to be a record. And again, increasingly we're seeing a move towards a lot of our view models being static records that don't have mutable states. Okay, so they're immutable. The idea behind using some of the things like reactive and stuff like that is that as the application states, it will bubble up a new version of the state. And so essentially those will be exposed as a feed back up to our application. So the actual view model really shouldn't change state, just the contents of the feed should. Okay. But since we're not using those, what we're going to do is actually bring in a product as part of the constructor here. And that will get exposed out as a property as well. So that's as simple as our view model needs to get. The final thing we need to do is actually go to our second page and actually tell it where to display the information about our product, because right now it's not got anywhere to show it. So we're going to put a text block in the middle of the screen, and we're going to bind that to the product.name, remembering that on our second view model, this product is actually the name of the property that will get exposed as well. And so we're going to basically take the name of that product. We're going to change the font size so we can see it. And we're going to put it right in the middle of the screen. Okay, and we'll give that a bit of quick run. Okay, so it's loading our products. Click on a product, takes us to our second page showing the details of that product. Now, interestingly, when I go back to the main page, it's having to reload those. Okay, so this is a bit of a thing about the sort of the page experience on UWP and WinUI, is that essentially as you're navigating between pages, there's this sort of caching model that's there. And essentially, if you don't want it to refresh, then you can set the navigation cache model to required. And that way, as we navigate between those, it's actually not going to repopulate or regenerate that page for us. And so we should end up with a much better navigation experience back and forward there, because it's not reloading data all the time. Okay, so I click on a product, go forward, go back, and it doesn't reload the page, and click on another product and shows the detail of those products. All right. Okay, so just in summary, want to highlight a couple of the customers that are using the Uno platform. TradeZero is one that's been basically building a very sort of consumer-centric user experience using the Uno platform. They've got a long-term strategy of making it available across multi-platform. Tool that everyone probably is familiar with, NuGet. So let's just have a quick look at NuGet. There we go. Okay, so this is our NuGet gallery that we're all kind of familiar with. I don't know whether most of you have seen it, but there's a new option over on the right-hand side, actually not that new these days, that opens the NuGet Package Explorer. So I can click on that. It's going to open the NuGet Package Explorer for this specific package. And so this is actually all powered by the Uno platform. Okay, so it's basically downloading the NuGet package into the browser. It's extracting it, making the contents available so you can browse it, so you can take a look at things like the manifest for the package. You can take a look at its contents. You can then drill down and have a look at the various libraries that are in there. If you click on a logo, it shows that in the screen. The various DLLs, you can take a look at the debug sources, etc., as part of your application. So this is actually quite a useful tool. If you're ever wanted to take a look at the contents of a package without having to download it, unzip it, extract it, etc., you can do that all within the browser now. There is actually a Windows app for that as well. Okay, Kahua. So this is a sort of a large-scale, sort of enterprise-based application, and they're migrating essentially from an old WPF-style application to the web. Okay, and they're doing that using the Uno platform. So the idea there is that they can take all of the existing source code that's all written in .NET and move it forward into the web without having to rebuild it all. And finally, the Uno calculator. So this was the original calculator that Microsoft shipped back in the 90s. Exact same source code, brought all the way forward, and is now available across all of these devices. So we can actually see that running again in the web here. So this is actually the same calculator that they shipped back in the sort of the 90s. Obviously, it's been reskinned slightly, but essentially the core workings of it and the calculation module is all the exact same source code. Okay, so in summary, basically what we've covered off today is basically the WinUI plus Uno platform capability. So the idea of taking a WinUI kind of concept and having it run everywhere. What's really interesting for a lot of people is the web support. But interestingly, we're talking to some Chinese developers, and they're expressing a lot of interest in the ability to take it to Linux and actually even to support things like Windows 7 and Windows 8, because you can take the WPF-based application and run it on those older platforms as well. Unlike a lot of the other cross-platform tools, the goal with the Uno platform is this pixel-perfect rendering, and then for us to support the whole developer lifecycle from development or design all the way through development and into production. As part of the ongoing tools of the platform. Calls to action. If you want to get started with the Uno platform, go and download it and try it. It's available at the platform.uno. The team is very responsive on Discord, and if you've got issues, make sure you log them on GitHub. If you've got feature requests, make sure you log them on GitHub. The team's very active at listening to what's coming through on GitHub and actioning on those. Okay. I'm going to hold there and leave this on the screen for a few minutes. If you have the SSW app, then make sure you scan the QR code. If you don't have it with you right now, you can download it and scan later on. In the meantime, if there's any questions, I'm happy to take them from the floor or from online. Okay, so we have one question online. Can I zoom in on the code, please? Yes, I did zoom in. Hopefully it was in time to see most of the code. If you need any of the code afterwards, just let me know. I'm more than happy to share the code. The commerce sample app that we saw in Figma, obviously it's available in the Figma template, but it's also available on the GitHub repo. It's on Uno platform/uno.samples. It's one of the samples that's available for the Uno platform there. Will there be a designer like there is in WPF, or is this just hot reload type, or is one coming? So to date, there's no work being done on a designer of sorts, and this is unfortunately true both from Microsoft all the way across the ecosystem. There is some work being done by Microsoft, particularly for MAUI around a live previewer based into Visual Studio that basically surfaces up what your app's currently looking like on the device and mirroring it. It's kind of like a pseudo design-based experience. But right now, the focus from at least the Microsoft perspective is on things like Hot Reload and you know the savings and the benefits to developers from that perspective. So I don't see a designer coming anytime soon. However, if you want to get started for the Uno platform, you can actually go in and start up a UWP app. You can use Blend as your designer, or even the Visual Studio design surface for UWP, and then you can reuse that XAML line for line in your Uno-based applications. Okay, so the XAML that's used for Uno is exactly the same as the UWP. In fact, for UWP applications, there is no Uno part to it. You're running essentially a UWP, or in the future case, a WinUI application, and so you know the Uno componentry there is pretty minimal. What's the main difference between MAUI and Uno? So the big difference is in the strategy they've taken for how they're abstracting for the different platforms. So if we look at the way that Uno, their sort of view on the world is they basically come from a very Windows-centric. So they basically said, okay, we're not going to provide any level of abstraction for Windows. So whether that be UWP or WinUI, if you want to build a Windows application, you could do so with or without Uno involved. If you want to then take that Windows application across to other platforms, that's when you engage with Uno, and it provides the abstraction that matches essentially the specification for UWP or WinUI across those other targets. MAUI, on the other hand, provides an abstraction for all platforms, and it does so using, well, in the case of Xamarin Forms, it used to be renderers, and now it's a bunch of handlers. And so it's kind of like a different perspective on the world. There's, you know, it's horses for courses. Different developers will prefer different approaches. There are differences in terms of supported platforms. So in the MAUI space, their targets are iOS, Android, and Windows, and macOS. In the Uno space, it's those targets plus Linux and the web on top of that. what else can I tell you about the differences? It's a longer conversation I'm happy to have with people. It's not a natural preference of one over the other. It's just that they have some fundamental differences. How different is the UNO XAML from WPF and UWP? Okay, so essentially the XAML for UNO is the exact same XAML that is used in UWP. In fact, you can build a UWP app without any UNO bits involved. Okay, it's still, and then you can add UNO on top of that to provide support for those other platforms. Okay, so it is exactly the same XAML. Now, where you may run into some limitations is some of the capabilities have not been brought across from UWP into the other platforms. So there's obviously a prioritization of work that's gone on there to make sure that the stuff that makes sense for the other platforms has come across. And if they're very Windows-centric things, then sometimes they don't get brought forward to those other platforms. So the XAML is very different from WPF XAML. Well, it's as different as UWP XAML is from WPF. Okay. Any questions from the crowd here? No? All makes sense? Are we going to go out and build an UNO app tomorrow? Look, the best way to do it is to get started with it and just download it, have a play, see what you can come up with. I think that the capability of building a web app using WASM, using XAML and C# is just a great experience. I'm not a native web developer, so the more I can stay away from things like JavaScript, the better. So it works from that perspective. But being able to take the same code and actually have it run across the different targets without having to redevelop it is definitely a power to the platform. So. Okay, one more question. Is there support for hybrid apps with UNO bringing Blazor components like Maui does? So I'll answer that yes and no. I mean, yes, you can build an app using UNO that has a web view and that brings in web components. It doesn't have support in the same way as Maui Blazor does. I think the guidance there is if you're going to build an app, essentially a Blazor app that you want to run in a native shell, the story for that today would be to use Maui Blazor. It doesn't mean that you couldn't do it for UWP, on the UNO platform. It just means that right today that's not a core developer scenario for the platform. One of the interesting permutations that we have seen is that, or one of the sort of things that has been built on UNO is taking various web components and actually making it available across the suite of UNO platforms. So for example, if you need a markdown viewer or a markdown editor, rather than building a native experience in XAML, you can actually take a web experience and package it as an UNO control and have it running on various platforms. And so this has been used in a couple of scenarios. Once where we've taken the Monaco editor, so this is actually the editor that powers Visual Studio Code, and actually made it available within an UNO-based application. Okay, and so that whole JavaScript library, which is essentially what it is, can actually be packaged as an UNO control and made available across the various platforms. So yeah, that's quite a powerful capability of the platform. So. All right, let me just progress to the next slide. So there's a QR code for earning SSW points. And I think that there's one more QR code after this, is that right? Okay, feedback QR code. All right, so if you've got feedback on today's sessions, please provide feedback on the session. It always really benefits me to learn what I could do better and to know what other information you might want on the UNO platform, etc. So scan the code, provide some feedback, and that would be fantastic. Okay, so Matt's actually got another question before we sign off. What's the app and page lifecycle management like, similar to Xamarin Maui? So the app and page lifecycle exactly matches the page and app lifecycle for UWP and WinUI. So pages have a natural So they have a sequence of events that get bubbled up. So you have onNavigated_to that basically gets called when you arrive at a page. You have onNavigated_from, or onNavigating_from when you're about to leave a page, onNavigated_from when you leave a page. And your app has similar lifecycle things like when it started and suspended, etc. So it's kind of fairly similar to, well, again, on Windows it's exactly the UWP model. On the other platforms it's basically abstractions that sit on top of those. So. Yeah. Okay, with that, thank you all for listening in or for attending. I'm going to hang around for a few minutes. If you've got questions, feel free to either broadcast them on the web or come have a chat with me afterwards. Thanks very much, everyone.